everyone. I'm Jean Palasi Valencia, this IT2 of San Sebastian College, Recoletos. And now in this video, I will present the CPU scheduling algorithm. But we will focus on more priority CPU scheduling. I choose this topic to discuss because I'm interested with this and want to challenge myself to have more deep understanding in this CPU scheduling. CPU scheduling is a fundamental component of modern operating system, essential for managing the allocation of CPU time among competing processes or threads. Its primary goal is to ensure that system resources are used efficiently, fairly, in a way that meets the specific requirements of the system and its users. CPU scheduling have various types, and they are: the first is first come first serve. It prioritizes processes based on their arrival time and the shortest job first. This algorithm selects the processes with the shortest execution time, and the third is round robin. Round robin processes are assigned a fixed time quantum and run in a cyclical manners rather, and the last is priority scheduling. And the CPU is given to the highest priority processes, but I will emphasize that we will focus on priority scheduling. Priorities can be either dynamic or static. Static priorities are allocated during creation, whereas dynamic priorities are assigned depending on the behavior of the processes while in the system. To illustrate, the scheduler could favor input or output intensive tasks, which lets expensive requests be issued as soon as possible. Priorities may be defined as internally or externally. Internally defined priorities makes use of some measurable quantity to calculate the priority of a given process. In contrast, external priorities are defined using criteria beyond in the operating system, which can include the significance of the process, the type, as well as the sum of resources being utilized for computer use, user preference, commerce, and other factors like politics, etc. Priority scheduling can be either preemptive or non-preemptive. Preemptive: this type of scheduling may preempt the central processing unit or CPU. In the case the priority of the freshly arrived processes is greater than those of the existing processes. And the non-preemptive, this type scheduling algorithm simplify places the new process at the top of the ready queue. Indefinite blocking, otherwise called starvation, is one of the major issues in concerning priority scheduling algorithm. It is a state where a process is ready to be executed but faces a long wait in getting assigned to the CPU. It's often possible that priority scheduling algorithm can make a low priority process wait indefinitely. For example, in an intensely loaded system, if there are a number of higher priority processes, the low priority processes may never get the CPU for execution. A remedy to starvation is agate, which is a technique used to gradually increase the priority of those processes that wait for a long period in the system. So I have here a given example of priority scheduling algorithm. I have here a 5 processes with their burst time and priority. For process 1, it has a 11 millisecond burst time with priority number 2. For process 2, it has a 2 millisecond burst time with priority number 1. For process 3, it has a 3 millisecond burst time with for priority number For P4, it has a 6 millisecond burst time and 5 priority number. For P5, it has a 2 millisecond burst time and it has a 3 priority number. Then I will show you how to solve it using Gantt chart. I have here our 5 blocks of Gantt chart. So since the P2 have a highest priority number, I put it here in the first block. Then the P1, it has a second to the highest priority number, so I put it here in the second block. Since the P5 has a third to the highest priority number, then I put it here in block 3. For the fourth block, process 3 have a 4 priority number, so I put it here in the fourth block. And the P4 has a lowest priority number, so I put it here in the last block. Since the P2 is the first process or first job, there's no needed awaiting time. So I put it here in 0 awaiting time. So since the P2 has a awaiting time of 2 milliseconds, I put it here. Then P5 is the third priority number. It has a 2 burst time, which is the awaiting time. Then I just add the burst time of P2 and the P5. So the answer is 4. Then for the process 3, it has a burst time of 3, or which is awaited time. I just add the awaiting time here and the burst time of P3. So the answer is 7. For the P3, for the process 4, it has a 6 burst time, which is the arrival awaited time. Then I just add the awaited time of P3 to burst time of P4. So it made it, the answer is 13. Then for the process 5, it has a 2 burst time, or which is awaited time. I just add it here. 13 plus 2, then the answer is 15. Then this is the Gantt chart. And for the average of waiting time, I just add all the awaited time here. Then 0 plus 2 plus 4 plus 7 plus 13 plus 15, and just I divided it in number of processes or job. Then the answer is 8.2. This is the burst time. Importance of selecting the right scheduling algorithm. Choosing the right CPU algorithm is crucial for optimizing system performance. The choice of algorithm can significantly impact system responsiveness, throughput, and fairness in resource allocation. Encouragement to explore other CPU scheduling algorithms. While priority scheduling is one approach, there are several other CPU scheduling algorithms to consider, exploring other algorithms such as first come first serve, shortest job first, round robin, and more can help in making informed decision in which algorithm is best suited for a specific system or application. Also, it is essential to understand the strengths and weaknesses of various algorithms to make the right choice and optimize system performance. The advantages of priority scheduling: it allows for task prioritization, making it deal for real-time system and ensuring critical tasks are handled promptly. It offers fine-grained control over resources, allocation, and customization to meet specific system requirements or performance goals. And then disadvantages is potential for low priority task starvation, fairness issues, complexity in managing priorities, risk of deadlocks in system with priority-based resources allocation, increased context switching, overhead, potential misconfiguration, and challenges, and a lack of determinism compared to other scheduling algorithms. And the real-world example of priority schedule CPU algorithm is certainly one real-world use case for priority scheduling is in the context of emergency medical services. In an emergency room or ambulance dispatch system, priority scheduling is used to allocate medical resources such as doctors, nurses, paramedics to patients based on the severity of their medical condition. Patients with life-threatening injuries or condition are given the highest priority, ensuring they receive immediate medical attention and potentially life-saving treatments. This prioritization system helps save lives by ensuring that critical patients are treated promptly, even during busy periods in healthcare facilities.